Today, we are diving into one of the most powerful and frankly, most important ideas in all of science, Bayes' rule. It's this surprisingly simple formula that gives us a rock-solid, logical way to change our minds when we see new evidence.
I mean, really think about that for a second. We do this constantly, right? You hear a news report, you see some fresh data, a friend gives you a tip, and your internal picture of the world, it shifts, maybe just a tiny bit. Well, Bayes' rule is basically the instruction manual for that shift. It's the engine of rational belief change. So let's see how this thing actually works.
To really get why the Bayesian way of thinking is such a big deal, we first need to understand its rival. You see, in the world of statistics, there are two kind of competing philosophies about what probability even is.
So on one side, you've got the frequentists. Picture them like treasure hunters. They believe that for any question, there's one single true answer out there in the world. You know, the true height of a mountain or the exact bias of a coin. Their job is to find it by just taking tons and tons of measurements. The answer that pops up most frequently, well, that's probably the right one. But then you have the Bayesians. They're more like detectives. They don't really buy into this one true value idea. Instead, they see a whole spectrum of possibilities, and each one has some degree of belief assigned to it. And every new piece of evidence, every single clue, lets them update their theory and sharpen their focus on what's most likely to be true.
Okay, that might sound a little academic, right? A bit abstract. So let's make it super concrete with a fantastic example. Let's imagine we're helping out a marine archaeologist who's just made an incredible find from an ancient shipwreck. So inside this old waterlogged box, she finds two coins, and they look completely identical. But here's the twist. She knows one of them is a totally normal, fair coin. 50-50, heads or tails. The other one, though, is rigged. It's been weighted so that it lands on heads 2/3 of the time. We reach in, we pick one coin at random. Our mission, figure out which one we're holding.
All right, so before we do anything, before we have a single shred of data, what do we believe? Well, since we pick the coin totally at random, it's a simple 50-50 shot, right? We can picture this as a space of all the possibilities split right down the middle. There's a 50% chance we're living in the fair coin universe and a 50% chance we're in the rigged coin universe.
Now, we can break this down even more because we know the rules of each of those universes. In that fair universe, half the time we're going to get heads, half the time tails. And in the rigged universe, it's 2/3 heads and 1/3 tails. Now look closely at the diagram. See how that rigged heads box is visually bigger than the fair heads box? Keep that in mind. It's going to be a huge deal in a second.
And here we go, the moment of truth. We take our chosen coin, we flip it, and it lands on heads. This is our new evidence. It's our first clue. So the question is, how does this one single piece of information change our initial 50-50 belief? Okay, this is where it all clicks. We know the result was heads, so we can just completely ignore the possibilities that ended in tails. They're irrelevant now. Our new world, our new reality, consists only of the two ways we could have gotten heads, either from the fair coin or from the rigged one. So in this new, smaller world that's only made of heads, which piece is bigger? Visually, you can see that red rigged heads box takes up more space than the yellow fair heads box, and that gives us a powerful intuition. Getting a heads makes it more likely that we're holding the rigged coin. That visual intuition we just had, just comparing the size of those boxes, that is exactly what Bayes' rule does for us. It's a formal engine that performs that precise calculation. It takes that gut feeling you get from looking at the diagram and turns it into a mathematical formula that tells you exactly how much your belief should shift.
And here it is in all its glory. Now I know, it looks a little intimidating with all the P's and the brackets and lines, but it's really just telling a story. It's saying the probability that our theory is true, given the new evidence we just saw, is equal to, well, you know what, let's just break it down piece by piece.
Let's stick with our detective analogy. The posterior on the left, that's our updated belief. It's our final conclusion, the thing we're trying to figure out. To get there, we take our prior, that was our initial suspicion, our 50-50 starting point, and we multiply it by the likelihood. The likelihood is just a measure of how well the clue, getting a heads, fits with our theory. Then we divide that whole thing by the evidence, which is basically the overall probability of getting that clue in the first place. So, when we plug all the numbers from our coin problem into this belief engine, our 50% prior, the 1 in 2 chance of heads from a fair coin, the 2 in 3 chance from the rigged one, what pops out? We find that the probability we have the fair coin after seeing just one heads has dropped from 50% all the way down to about 43%. Think about that.
Just one flip gave us a really significant update to what we believe.
But here's the thing. The real magic of Bayes' rule isn't just about doing a one-time calculation. No, its true power comes from its ability to learn, to refine our beliefs again and again and again with every new piece of evidence that comes in. It's this beautiful, powerful learning loop. You start with your initial guess, your prior, you get some new evidence, you use the rule to calculate a new, updated belief, the posterior. And here is the absolute key. That new, smarter belief becomes your prior for the next round. So if we flip the coin a second time, our starting point is no longer 50-50. It's now 43-57.
And this is the result. This visualization is it's amazing. It shows how even if you start with a completely wild, incorrect guess, see that red curve way over on the right? The relentless, steady weight of the evidence, processed through Bayes' rule, flip after flip, literally drags your belief towards the truth. And notice, the curve doesn't just move to the right spot, it gets narrower and sharper. That represents your confidence growing stronger and stronger.
Okay, this is all great for figuring out ancient coins, but why is this one formula so incredibly important in the real world today?
Because this logic, this engine of belief, it applies absolutely everywhere. The source material gives this great example of a starship captain trying to figure out if a planet has life based on a single probe's report. The stakes are way, way higher, but the logic is exactly the same. What's the probability of life given this test result I just got?
And you interact with this way of thinking every single day. You just might not realize it. That spam filter in your email, totally Bayesian. It's asking, what's the probability this email is spam given that it contains the word lottery? A self-driving car is constantly asking, what's the probability that's a pedestrian given the pixels my camera is seeing? It is the grammar of science, it's the logic behind AI, and it's the engine of how we learn from data.
So we'll end with this thought. Bayes' rule gives us this clear, rational, mathematical framework for changing our minds. It tells us precisely how much we should shift what we believe based on how strong our initial hunch was and how strong the new evidence is. It's a model for clear thinking. Which kind of makes you wonder, doesn't it? What evidence would be strong enough to make you update one of your own deeply held beliefs?